Thanks, Kate, and hi, everyone. Yeah, we're going to talk about information systems this week, and then my favorite type of information systems, the geographic kind. An early warning that we may go over by a couple of minutes tonight. There's a lot of content in here, and I've added a nice little knowledge check section at the end. So if we're good on time at the end, we'll go through it, and if not, we'll judge from there. But we'll get right into things. If you haven't met me yet, I'm Robert Harris, GIS professional and emergency number professional. Absolutely 100% a map nerd, geographer by trade, and I will be the person fighting for the window seat if we're ever flying together. I've got about 15 years championing GIS for public safety, and I'm getting extra gray hairs reading this next number, but nearly 40 years of making maps. Growing up, we always had to sit together at the dinner table as a family. We didn't have to talk to each other, but we had to sit together, and often we would just find some good reading material. My reading material of choice was the, which probably is not a surprise to those that know me, the Halifax Dartmouth Map Guide. And when it was a bit of a boring meal, I would doodle in the maps. And recently, my mom sent me one that she found when she was cleaning out. And I took a peek at some of my doodles and compared them to present day, and noticed the province of Nova Scotia decided it liked my suggestion for putting a new exit on the circumferential highway there. But they didn't take my suggestion of putting a rail station next to it. So you win some, you lose some. Okay, so for tonight, we have a couple of topics I want to go over. We're going to do some background knowledge on Geography 101 and GIS 101 to bring everybody up to speed. We're going to really dive into 911 information systems. Then I'm going to pull everyone back out of the weeds a little bit and talk about some GIS benefits for our space, some GIS uses in our public safety space, and then start to dabble in some next-gen 911 prep. And then depending on how the time is at the end, we're going to do a bit of a knowledge check. So digging right into things, we're going to spend a good couple of minutes talking about hopefully most people's favorite planet, our little third rock from the sun, and currently the only astronomical object to have both life and a crispy Diet Coke. You can draw whatever correlation you need between the two, but the thing to really remember is our little terrestrial lumpy potato is very hard to measure perfectly. And if you're ever at a party and someone asks you what shape the Earth is, it's a trap. The only correct answer is that it's Earth-shaped, and all of your English teachers are probably horrified that you're using the definition. You're defining the thing with the answer. So what's happening is our little lovely blue planet rotates, and as it rotates, much like if you were on the merry-go-round as a child and you were spinning the thing and everybody flew off the edges, a similar sort of thing is happening with the Earth. So as it rotates, it tends to bulge out a little in the middle and get a little flatter at the poles. A phenomenon I'm familiar with myself, and if anyone ever comments about it on you, you can just say it's just the rotation of the planet. We like to simplify the Earth's shape with a number of different methods. You may have heard the term geoid used before to represent a bit of an idealized ocean surface. And we have an entire science around measuring the planet called geodesy. And geodesists spend their entire lives coming up with new and better ways to measure the planet, coming up with better shapes, easier shapes to measure. And those easier shapes make for easier math. Because believe it or not, all of those things you hear about there being up, down, left, right, you know, even north, east, south, and west are all constructs we've made up to make measuring the Earth easier. And none became more obvious than in December of '72 on the Apollo 17 mission. Astronaut Harrison Schmitt took a picture of our big blue Earth, sent it back to NASA to get developed and published. And NASA had to go, whoops, hold on, we can't publish this because there is no up or down in space. And the picture they took had the Earth upside down, and they had to basically take this image, rotate it so that you didn't freak out that Antarctica was at the top. So keep that in mind. Earth is hard to measure. we like to simplify things. In fact, almost every map you've ever seen has been our attempt to flatten that 3D shape into a 2D flat thing to make us do things. And the reason we do that is so that we can locate any point on the Earth. If you can flatten it into kind of a 2D space, you can represent just about anything with a bit of a coordinate system. The problem, and if you've ever taken your Christmas clementines and you get that really good one to peel off in one big go, if you ever tried to lay it flat, you'll notice that, well, part of it will rip or peel or stretch or distort. And that's because there's no way that you can take a 3D thing and flatten it to 2D without creating some sort of distortion. So every map you've ever seen has distortion built into it. It's just, there's no other way. The only perfect way to represent the Earth is with the Earth itself. So two terms you'll hear a lot talking about this kind of phenomenon. One is projection, and really it's the math. It's the technique that we use to take that 3D thing and flatten it to 2D. That geometric transformation, the math that we use to flatten it. And you'll hear the word datum a lot, which basically is the relationship between whatever the coordinate system is that we create and the Earth's surface that it's trying to represent. So basically, creating a reference point, a 0, 0, a null island, so that we can start to measure things on the Earth. Probably one of the most common coordinate systems you've heard of is we will say either lat long or XY, but it's longitude and latitude have become kind of our default for doing a lot of these measurings. So if we take a second to look at longitude, it's basically that one that kind of looks like a Terry's chocolate orange, and you've got all of these really long lines going from the North Pole to the South Pole. We call these long lines meridians, and we have a prime meridian. So like that prime, the first one that we measure from, going right through an observatory in Greenwich, just outside London, England. When we were establishing this meridian, there was a bit of a fight between London and Paris on where the prime meridian would go. London won. That's why it is where it is. Paris let them have it in exchange for the scientific community adopting the metric system. So you've got London to thank for your longitude, and you've got Paris to thank for your the metric system that we use. And from that prime meridian, we have 360 equally spaced lines, starting with, if we're going east, from 0 to positive 180, and going the other way to negative 180. And that basically allows us to measure our longitude anywhere on the Earth. If we look at dividing the Earth into two hemispheres, heavy being half, sphere being sphere, two half spheres, we have eastern and western. If you're having trouble remembering which one's longitude and which one's latitude, remember that in longitude, all of the lines are the same length. They're all longitude. And no matter where you are in Canada, it will always be negative. So we are on the negative side of London. Where I am just outside Halifax, we're pretty close to about negative 65 degrees from the prime meridian, but you may sometimes see that as 65 west. Just remember, when you see west, it's really secretly just negative. Latitude, on the other hand, is measured vertically north and south. Its main line is the equator, and there are 180 parallel lines ranging from 0 at the equator, plus 90 at the North Pole, negative 90 at the South Pole. About 40 minutes north of here, we have a lovely little sign, because we're just about at that 45-degree mark here, saying you're halfway to the North Pole. Obviously, there's a lot more work to getting to the North Pole than just driving on that highway, but it's just a way to remember kind of where you are. So again, if we split it into two hemispheres, we've got our northern hemisphere, southern hemisphere, and the trick for remembering this one is that all of the lines are stepped kind of like a ladder, and ladder almost sounds like latitude. So that's how the trick to remembering that one, and they will always be positive for Canada. A datum that you're going to hear a lot about is the WGS 84 datum, which is the World Geodetic System of 1984. And what it attempts to do is say, hey, you know, that lumpy potato earth surface we have, it's really hard to measure. So what if we just had a simplified ellipsoid that makes the math a lot easier? Just measure from that. And that's what it is. It is used to measure our coordinates. That data is also used by wireless service providers, by GPS satellites, and a whole lot of other applications as an easy way to give you a location. That geoid we talked about, we call it a theoretical ideal. So basically, if we didn't have currents pushing the ocean around, we didn't have wind building up water here, there, and everywhere, or temperature, you know, making the water surface expand where it's warmer, what would that theoretical ocean surface look like? That's the geoid. There's some places where that theoretical is actually the same thing as sea level, the actual mean sea level, but for most people, it's a little bit off. It's also the same thing that we measure our height from. So if you get z-axis coordinates coming in on your wireless calls, the height is actually from that ellipsoid. If you look at the top left of the diagram, you'll see that there's a little bit of space there where that lumpy potato earth is actually below the ellipsoid. And that's what's happening for most of us here in North America. For a long period of time, we had a lot of glaciers pushing down on Earth. Our Earth is quite low, lower than the reference ellipsoid. So when you get your height delivered to you, oftentimes, if you're getting the raw number, it's going to be a negative number. Doesn't mean you're underground, just means that when we're doing all of the simplified math, you're below that orange line. And a couple of fun little notes. We say lat long a lot when we're talking about latitude and longitude, but really we write it as long lat. So we always write like -65 plus 45, which is pretty close to where I am. And really that's long lat, not that long. So that one to think about. And the other point, on the map that I have, we have on the bottom right, that 0 degrees of latitude, that equator, the red line, and the intersection of it with the green prime meridian, 0, 0. For us map nerds, we like to call that Null Island because it's 0, 0. It's in the Atlantic Ocean off the coast of Africa. Please ignore the one that's in your study guide. I know that it sounds terrible. I don't know who built it, but it's absolutely incorrect. It's wrong. It shows Null Island coming ashore in Africa. That didn't happen. It's just a horrible map. Ignore it. And hopefully NENA fixes it in a future version. So Robert, why did I need to know that? Here's why. These ellipsoids and other fun things are used when we're trying to calculate where wireless colors are coming from. Now, it's close to Valentine's Day, so I have a little, Romeo and Juliet heart in the top right corner of my slide talking about time and math. And when we're thinking about location calculations in this space, know that the more time you have to make a calculation, or the more accurate of a time that you have, the better the math gets and the more accurate of a location you get. So we'll keep that in mind as we go through our examples. But the first one I want to talk about is cell tower triangulation. This is something that if you take calls today, that you've seen it many times. We've got these two classes of service that we see a lot. Wireless phase 1 was our first attempt to try to figure out a really good location. And what it's doing is it's giving you a general area of the tower that routed that call. Wireless phase 2, we got a little bit better. It's still an estimated XY of the color. It's really a triangulation of the signal strength and the angle of the signal that's hitting your device. So a tower is sending out a signal. It doesn't know where you are, but if it thinks, oh, we think you're between this kind of level of strength and this kind of level of strength at this angle, and if we can get enough towers, we can kind of narrow it down a lot narrower, but it still can have quite a bit of uncertainty that comes with it. Another common one is GPS, which is kind of like Kleenex and tissues. GPS is a name brand, so it's like the Kleenex. What they are what GPS is a brand of GNSS, a Global Navigation Satellite System. And I know Eric talked about GPS on his week, so I won't go fully into what it is. We know it's got a constellation of satellites and ground stations. But what's important to remember with GPS is the ground stations know where they are, the satellites know where they are, and what the satellites do is they send out signal timings to your receiver, whatever your GPS receiver looks like, whether it's a handheld, whether it's something built into your phone. That signal knows when it left that satellite, and it knows what time it arrived at your device, and it knows how fast it was traveling and uses the math in between to figure out the distance. So the secret to GPS is accurate clocks, really accurate clocks. And with that, it can calculate your latitude, your longitude, altitude, course, speed, all of the things, and really help kind of improve our location accuracy around the world. And then the latest kind of kid to join this party is our device-based hybrid location calculation. So again, the name brands here that you may have seen are Hilo and ELS, and I know they were talked about on earlier weeks. So one's Apple's proprietary method, the other's Google's. And what these are, they're versions of advanced mobile location, or AML. And they say, hey, okay, we already know that the more sources we have of a thing, the more accurate location we have. Well, let's get as many of these sources as we can, and let's combine them all together and get a really accurate location. And you can see the little blue, I hope they're coming across blue on your side, areas of uncertainty around our little blue dots. And you can see how they kind of get smaller and smaller the more sources we have, the better location we're able to calculate. And the real big one here is that this AML calculation, the calculation's happening on the device as opposed to that cell tower one where it's really happening on the network. So that's why we're getting more accurate results. The use of this kind of location calculation has been mandated by our friends at the Commission for 4G and 5G networks by April of 2024. So that date's passed. So if you've noticed over the last kind of year and a half that, hey, my location accuracy on my calls has gotten way better, this is why. Okay, so we're master geographers. What about GIS? What if I don't even know how to spell GIS? So if this is you, GIS is short for Geographic Information Systems. And really what GIS is, a lot of people think that it's just data, but it's really that entire bucket of things. It's all of the things. It's the hardware, the software, the people, the procedures that they have, and the data, and it ties all that information together. It displays it geographically, and it stores it in a database. That's GIS. So GISs are used to store information, information about places on the Earth. And we have a couple terms that we like to use for that data, whether it's GIS data, spatial data, mapping data, all of those words that we use interchangeably. But this is what we're talking about. Information about a location, or information plus geography, aka location. It's not one specific mapping program. It's really that complex mix, that melange of the database management, the display technology, all of the fancy, cool analysis tools that come with it. All of it is what GIS is. And for those that are really like, okay, well, now I know I need one of those. When it comes to GIS planning, and around my globe here, we have all the things that GIS commonly does for organizations. Some tips for those that are looking to plan or build a GIS from scratch. These things, if you're used to project management, these are not surprises to you. To have a successful GIS, you need, a good database design, you need good training, you need good data, garbage in, garbage out kind of thing, but great data in can get great, results out. Continual planning, what kind of outputs are you looking to produce? Those kinds of considerations have to be taken into consideration. Poor planning, on the other hand, leads to stagnant GIS, unusable or corrupt data, a loss of your investment, so the money you spent on hardware and software, the loss of the time you put into it, you're going to end up with a bunch of technology debt, and ultimately it's just going to fail. So take the time early on, figure out what your organizational needs are, before you ever buy a piece of software, a piece of hardware, or even design the thing. So figure out those needs from the beginning and then do it continuously. Develop. GISs develop and adapt over time. So should your plan, making sure your goals and objectives are communicated is really the key to success there. Digging deeper into data, and it's hard to see, but I've got my points, lines, and polygon shirt on here today. When we talk about this GIS data or this spatial data, mapping data, whatever your name is for it, we're talking about information that's referencing some sort of location or geography. The three most common ways of representing this data is with layers of points, lines, and polygons. And visualize these layers with attribution, so extra data, and symbology, how this thing looks, what color is it, what symbols are we using? That's symbology. And we do this because when you stack all these layers together, when you run analysis on them, suddenly you can see patterns that may not have been apparent otherwise in the data. Another term you might see around this is metadata. And I'm not trying to be cheeky with the comment, but it really is just data about data. It's summary information that talks about the data. Things like, oh, I used this projection, I collected it at this time, and this person collected it with this method. And here's some keywords that talk about the data set so that you can search it easier. That's metadata, and it's a little bit different than the actual data itself. Background knowledge done. Promise it gets better. So now we're going to talk about kind of the meat of tonight, and that's the 911 information systems and information systems in general, and how they all relate to what we do. So this is a NENA group. We're going to talk about NENA for a hot minute. You may have heard references to a bunch of REQs and STAs and INFs, and what the heck does that even mean? And just know that the 911 industry is heavily guided by quite a few standards and a heck of a lot of industry input. So NENA, the big mothership NENA, is an ANSI accredited SDO, Standards Development Organization, for 911 in North America. And they have a very rigorous standards development process. If anyone's ever been part of it, they know. Before these documents ever see the light of day, they have rigorous member reviews, thorough and continuous comment periods, and it's quite an extensive review process before these things are actually published and blessed by NENA. There's kind of four big buckets of documents that they publish. So INF are those informational documents. So they kind of have like good guidance and best practices and that kind of thing in them, but no hard requirements. An REQ of requirements documents, which basically says and gives guidance around, hey, if you're going to establish a thing like this, have considerations like that. They have the STA, the actual standards documents themselves, and they say, hey, they use words like must and shall and should and these kinds of things, and they define how things work together or how things must be shaped together or must be structured. That's what you'll find in standards, the STA standards documents. And then you'll have REFs, so reference documents, which are basically just, here's some bonus info about this other thing that's already published. And you might need to know this in order to implement this thing over here. And that's the kind of documents that's the kind of information you'll find in a REF. All right. When it comes to 911 information systems, I know we're moving into the wonderful land of next gen 911, but the study guide spends a considerable amount of time talking about E911 or legacy 911. And I'm going to take a couple minutes tonight because these questions will likely be on your exam. They were on mine. And you just need to know these terms. Even if they don't have an exact equivalent in next gen, it's really important to know them and know kind of what went into building the current 911 system. There's an entire section in your study guide that talks about DBMS. And if you've never seen DBMS before, it's basically those database management systems. Maybe it's a GIS, maybe it's not. But basically, it's that thing that people and applications use to interact with databases and the data within those databases. So some of the more common ones for E911, we have our SOI, the service order input. And this is basically, it's that file of updates. So, hey, I've signed up these new customers at these telephone numbers, and they need to get added to the system. So the SOI, also commonly called the 911 extract, it gets sent to whoever the DBMS is by a service provider, and you know, whoever's standing up the 911 network, and it contains a couple things. Mostly, it contains a customer phone number. Adds, changes, deletes. Hey, unlock this number, do this one. Here's the customer's address. Here's their name. All these other kind of good things. These records can get batched together, validated, and then they get processed against the master street address guide, the MSAG, to create records in an ALI database. And I'll get into that on the next slide a little bit deeper and kind of show you some of that flow. But I wanted to define the term first before we started looking at the diagrams. Next, MSAG, Master Street Address Guide, is really that list of street address information within a 911 service area. So it contains a bunch of things. It has address range information for the left side of the street and the right side of the street, street name, any directionals, north, south, east, west, suffix, so like street, drive, avenue, etc., community name, state or province, and a little thing called the ESN, or the Emergency Services Number, which is that 3 to 5 digit number that kind of makes the selective router know where and how to route your 911 call. So the SOI gets processed against the MSAG. It spits out information it spits out an ALI record, automatic location identification. And I've got a star there. If you've ever called it automatic location information, like I have, and probably will make that mistake 100 more times, that's not what's in the book. Even though that in some of the diagrams, it is in the book, the actual definition talks about identification. So these records are the end result of processing all of the data from the SOIs against the MSAG, and it stores these records in an ALI database. These records are accessed and displayed on your piece of equipment when you get a 911 call. So that ALI spill, that ALI dump, is really showing you the ALI record from the ALI database. Versus the selective router systems records, and these are it's an additional database of records, and this is what happens also when the SOI gets processed against the MSAG. But the output's a little bit different. This one has the telephone numbers and the ESNs. So it works a bit like an index, so that when that telephone number comes to the system when a 911 call is placed, it has the routing ESN. It knows when it hits the selective router how to route that 911 call to the right PSAP. So on the right, again, we have our DBMS system. You have our database in the middle there in blue, and then below that, it's an example of some data in a table. So data is often held in a table. Those tables are in the database, et cetera, and moves up the chain. We use a lot of different terms interchangeably to talk about kind of all of the different things in that table. So those columns, sometimes we call them fields, sometimes we call them columns. The rows, sometimes we call them records, sometimes they're rows, sometimes features. And then even the data values themselves, sometimes we call them values or attributes or elements. They're all used almost interchangeably. And if you're already confused, that's what happens when we start using a whole bunch of different words to all mean the same thing. And I don't blame you at all. So let's see this DBMS in action. So this is from figure 3.1 in your study guide. And we're going to start on the left with in red SOI. So you're a service provider and you have a new customer, and you're going to input that thing in the SOI, and that extract's going to go off to the DBMS, at Bell or TELUS or SaskTel. It's going to get processed and against the MSAG or the telephone number database, and it's going to spit out two different outflows. One is the telephone number and data, so like the customer name, the address, all those kinds of things. Everything that's in that alley record, and that goes and sits in the alley database. The telephone number and the ESN, however, which is the routing information, gets dumped out into the selective router. And all of these tables and databases all relate back to each other. We call this system relational databases because they all can relate back to each other with a key, and that key is the telephone number. So the telephone number is the connection between this one, and that's kind of how those records all stay intact. I've got some little green sunshines there, basically to call out so that if you're trying to remember, well, which one is stored where? Robert, I can't remember. So this is just pointing out the difference and why we have two different databases. One is TN and data, the other is TN and ESN, the routing data. If you're in an area with E911, you probably didn't see any of this happen. But these are the process steps that kind of happened when your E911 database was developed. And I won't go too deeply into it, just to show basically there was a rigorous process to define the data that went into your MSEG, to create your ESNs, to create all of your alley records, and there was an iterative data correction process that went behind it. But just know that there was an entire process in the chain, or there was an entire chain of processes. And the study guide does a good job of kind of going through these in more detail. And just know, while you weren't here to do this for E911, we're all here to do this again for NextGen 911. So it's likely you'll see a similar process when we're implementing NextGen 911 data. Further to that, NextGen 911 has a couple of different changes that are different than E911. Well, there's a lot of different changes, but some of the kind of key ones that I wanted to point out for folks here in NextGen 911, that location that kind of gets passed through the system, those values can be either a civic address, so something like a house number and a street name, or it could be a geodetic coordinate like that long. The concept of MSEG community goes away. It doesn't exist in NextGen 911. It's replaced with a richer hierarchy of administrative level boundaries. So instead of being forced to have one administrative thing, we have a nice list that we can choose from to help disambiguate our locations. And the call location will be delivered with the call and is used to route the call to the most appropriate PSAP, as opposed to the network calculating a location and having to be retrieved after the call is placed. So things to remember is your MSEG and alley databases are going to need to be brought into compliance with the CLDXF and GIS data model standards. So there is no MSEG, there is no alley database, but kind of similar flavors of some of that data will exist in other places, and they'll be guided by these standards. And again, there is no traditional alley database in NextGen as we know it today. It doesn't need one to determine location. Your location is going to be determined by, the software hardware of the device or the network, and it can be dynamic and may arrive as a location by value, which means it's going to have the hard-coded value, it's going to have the street address, it's going to have the geodetic coordinates, or it could be a location by reference where it gives you a reference link and the system has to go and dereference and figure out what the location value is and then use that to route the call. But like there's that ability to link a location reference value, there's also the ability to link a bunch of other data about the caller through something we call additional data repositories, or ADRs. And that these all get kind of, this ability gets unlocked with our NextGen system. So pulling back to E911, something that if you caught up on the other slide saying, hey, well, sometimes I've gotten issues when I've been trying to get either the ANI or the alley database, and I've had some issues, and I don't understand why this would happen. So the study guide goes through a couple of common issues, and when you kind of process them through, they all kind of make sense once you kind of know how that back-end system's working and knowing, oh, it's got to dip into this database, or it's got to dip into that database. And if it can't, you're not going to see this. And if it can't do this one, you can't see this one. So a common one is anonymous calls. So this occurs, if someone dials the 10-digit number, which is the same as the hotkey number, of that PSAP, and basically, dials right into that 911 trunk without going through the selective router, means that it's not going through the router. It's not going to go dip up into all of those databases like it normally would to go get that data. So it's not going to present to you because it never went and did the calls to all of those databases. We try not to use previously used numbers for PSAPs. It could happen, or it could be like me. I've got fat fingers. Sometimes I'll hit 4 or try to hit 4, and I'll really hit 5, and someone can just accidentally call into that 10-digit number and get you. Another one, no display. So if there's an issue trying to dip into that alley database to pull out the alley record, well, if there's something happens that it can't do that, then you're not going to get the alley record, and all the information that would have been in that record isn't going to display on your screen. So if the color name and address and all that kind of thing doesn't show up, it's because it couldn't get it. Record not found is one that can happen. Two kind of big causes for this one. One, someone's phone number has recently changed and it hasn't been updated in the system. So when that phone number, that relational key, tried to query those databases, it didn't find a match because it hasn't been updated yet. So it couldn't pull out a record for you. Or if it was a mobile phone number, they tried to query the mobile number and not the pseudo ANI that actually routed the call. So those are the common reasons for that. Party lines, if you're like me and you had a grandmother in rural Newfoundland growing up who had a party line, basically this is a couple of different customers all sharing one external line. At my grandmother's house, whatever her ring secret was, whether it's 2 rings or 3 rings, whatever, she knew her ring, and let's say it was 3. If it rang 3 times, it was for her. You'd pick up and you'd say hello. It was also a small town, so if it was like 4 rings or 2 rings, you'd still pick up and you just listen. But that's for another day. But if a party line is trying to call into 911, I don't know how many of these are left or if any are left. But obviously it can't figure out which of those endpoints made the call because they're all sharing one line. So that results in an ANI failure. Or it could be due to dual service. So this is what happens when you have the same telephone number ringing to 2, again, kind of like party line, but different, to 2 addresses. So let's say you're moving and you wanted continuous service at both for like an overlap period of time. And it can't figure out which one of those you're at. So this is typically why, we will only have one, and you pick a date and the old one cuts off and the new one starts, so that system can make that one-to-one match. All right, so now we're all caught up on 911 information systems. We're going to talk a little bit about some GIS uses, benefits, and then a little bit more next-gen 911 prep, and really dig into some of these things. So you've probably seen some of these benefits already, benefits to having GIS and good GIS data and mapping data, and a couple are on your screen here. One, really good data really helps your PSAP CAD systems. One, paint that full picture. It helps you geolocate the alley caller's location against other relevant information. You can say things like, oh, okay, well, this is where they're calling. Where's the nearest unit? Where's the nearest hospital? Where's the nearest fire hydrant? All of those kinds of things are more easily done if you've got good mapping data. GIS can be used to create your MSEG, your ESZs, your emergency service zones, the roads, addresses, all of that stuff that gets fed into an MSEG. You can use GIS to build it, to validate it, and make sure you've got really good and robust data quality checks to make sure your data is suitable for 911. Again, it can use it for geocoding, which basically is the process of adding a lat long to a piece, some sort of tabular data. So it's you're giving geography, you're giving a spatial location to something like an alley record, so that it can be leveraged in GIS and in your mapping applications. And we already know it's been covered before. And next gen 911, GIS data layers will be that fuel that enables several key functional elements in the next-gen #1 systems, like the emergency call routing function, like the location validation function. NG 911 can't happen without GIS. Some other applications and uses and services. One we've more common are some GPS-based telematics services. So in my SUV, it's got this. So it's got a little modem in the back underneath the spare tire, and it connects to the cellular network. And it's full on, got a full signal in there. It's got a GPS receiver. There's a little button I can push, and if I'm in an accident or whatever, I push the button, and it will connect me through the cellular network to a telematics service provider, and they often can use a GIS-based system to figure out where you are, figure out who your local emergency service is. Some vehicles have automatic collision notification. Mine's not quite that fancy, but basically they'll push the button for you essentially and transfer that call. This isn't mentioned in your book, but know that in Canada, all of these kinds of calls do not go directly to 911 first. They all go to some sort of telematics service provider or relay service before they go into the 911 system. And we also have a high number of mobile-based applications. So the E911 system, while we've tried to tweak it here and there to meet our needs, it does have gaps and shortcomings. There's a lot of new technology out there that can help us do our jobs a lot easier. So we're seeing it's more common, a lot more over-the-top applications, whether they be on your computer or on your mobile device. And these are used by PSAP personnel and emergency responders to fill some of those gaps that are in the current 911 system. My sister's partner is a firefighter here at the city, and every single one of them has an app on their phone so that when they get a call, they can all see it. They can all tell when they're responding, and that's just a functionality that doesn't exist in the current 911 system. But the application fills that gap. So they've gotten really popular over the last number of years, and it's important if you're going to use them. Just make sure that your PSAP personnel know about them and that they're trained on them, so that could be part of your overall 911 ecosystem. There we go. When it comes to GIS prep, another standard or a standard that I want to kind of direct folks to look at is a fairly newer one, the GIS data transition information document. So this document has a lot of helpful tips and tricks for preparing GIS data for this transition. It lays out some of those roles and responsibilities that key partners have during the transition, whether you're a number authority, or you're a GIS data provider, or you're a network provider. There's tips in there for everyone. It talks about how, and this is way more common in the US than it will be in Canada, but that your GIS data might need to be used to support kind of two things at once. So both the legacy MSEG and the new geospatial call routing mechanisms. And that if you are doing that, there may be additional attribution needed on your data, just things to be aware of. It talks about, ways of managing the use of abbreviations and domains and how to translate one to the other and how to parse your street address data and all these kinds of things and educates folks that, hey, we're no longer constricted to our old MSEG data restrictions. We can use capitalization in words. We can use French words finally. We can use special characters. All these things. It guides readers through that. And kind of two big things that it really reinforces. One, local knowledge is always key. So if you're trying to figure out something about a civic location, local knowledge will always help you try to figure out what it is. We often talk about, we should have, a 98% match to MSEG, but what does that actually mean? And is that kind of the metric we should be chasing? And really it kind of shifts our thinking to saying, hey, instead of chasing your MSEG, maybe we should chase our alley databases. So in theory, if it's in the alley database, it's a customer's telephone number and it's a valid endpoint. Now, there may be some junk in there or some test records or whatever, but really it's probably the alley database that we really need to be aligning to as opposed to the legacy MSEG. Okay, we got to the knowledge check. And I apologize that I probably spoke really quickly. I'm from the East Coast, it's what happens. But I was really hoping that we would have some time to do a bit of a knowledge check here at the end, just because there's a couple of key concepts that I really wanted to take a few minutes with folks. And if you're going through this presentation or you're rewatching the recording and you're going, oh my gosh, I don't remember any of this, that's okay. When I was, doing my own study group for when I was writing my ENP exam, I had to rewatch the videos 2, 3, 4 times. I had to write my test. I had to go down to the state of Maine to write it. And in the entire drive, I was not watching, but listening to all of the training videos. So if that's how you're feeling, just know that's okay. That's normal. That's literally how this thing goes. So a couple of kind of key concepts I want folks to remember if you remember nothing else from tonight. One, how E911 records come to exist. And we've talked about, SOIs, they go in, they get queried against the MSEG, and oh my gosh, I can never remember which one goes to the alley, which one goes to the selective router. My little green sunshines are back with some hints. If you can't remember whether data or ESN is being saved with the record, remember that data has A's in it, alley has A's in it. So data goes in the alley database. ESN does not have A's in it, but it does have an E and an S. So does selective in selective router. These are the tips that I use to try to kind of remember myself. And they're silly, and you may also think they're silly, but when you're sitting there writing the exam, you're going to go, oh, it's the one with the A. So if nothing else, remember which data record goes into which database. When it comes, oh, where's my mouse? There we go. When it comes to next gen, and I know you've seen most of this slide before. When we talk about information systems for next gen, I've added some things to this slide that I thought were missing. They're in blue and green. So in blue, if you're wondering, well, where does this GIS data that Robert's talking about go? Well, it gets fed into the system by probably a GIS data provider that's working on behalf of an LGA or a 911 authority. It goes through an interface. It's spatial data. It goes through a spatial interface. And there's a GIS database sitting inside this ESINet. And it's powering 2 functional elements, the ECRF, the emergency call routing function, and the LVF, the location validation function. And you see I've got my little green stars, one pointing to the LVF, one pointing to the ECRF, but there's a third one on the bottom left pointing to the LIS, or the LIS, or the Location Information Service, however you like to abbreviate it. But we're going to talk about that a little bit more. And know that, well, most of this is in your study guide. Not all of it is, but I'm going to try to lay it out just because I think it's important to know. In E911 world, those telephone numbers, they're pre-checked, right, against that MSEG, and all of the PSAP routing information, all of the responder information, it's all saved and preloaded in that database so that it's ready to go when the 911 call happens from that telephone number. There's no guessing. It knows what it is. It knows where it is. It knows the routing, and you can batch all these things together. And when you're validating the records, and they're ready to go, these records. In next gen 911, the concept of records is a little bit different. So, let's say you're setting up a new customer. There's no real SOI in the same sense, but those addresses do get pre-checked. They get checked against the GIS data that was provisioned in, and it does that with the LVF, the location validation function. The location validation function will say, oh yeah, this is a good valid address. I matched this to something in the GIS data. You're good to go. When this call comes in, it should be able to route because I found a match. And that match, I know the geography, I know the geography of the response zones, I'll be able to route this. So that record gets saved in the list. That list can get used as, like, again, that dereference, for the dereference locations that come in as a location by reference, but it does not save that PSAP routing and responder information. It's saving the location object itself. It will still need to go and query that GIS at call routing time to route the call. So there's no pre-save. It's live, it's dynamic, it routes as it routes. And the other thing, I know on Eric's, I believe it was Eric's week, we talked about the loss protocol, kind of that the communication method that all these things are querying each other. The current iteration of LOS does not support batching. So while your E911 records can be batched and rechecked and revalidated periodically, there's no batching in the list. So it's currently one at a time. They're looking to enhance it, but currently it's one at a time. Recheck if you're rechecking them. And again, the list doesn't save your customer's name, the other related information. All of those things are stored in additional data repositories that get queried when the call happens. So it's a little bit different. There's no ALI database. There's no, all these things. A lot of it is happening live when the call comes in. And again, annoyingly, this is not in your study guide, but I did want to take a minute just so that folks are clear kind of what's happening with these two different data, two different routing methodologies. And if you don't like diagrams, I've done it this way with a little bit more text. We've talked about the E911 routing, locations not delivered as part of the call. The customer phone number, that key, that relational key, queries the databases to figure out the routing information and the caller's address. Goes to the ALI database and gets the location information associated to the telephone number, the address, the person's name, etc. And then the other query to the spatial selective router database to figure out the routing information. Whereas in NextGen, the location is delivered as part of the call, and we can route the PSAP without having to go and look up things with that telephone number. Those telephone numbers, we call them endpoints, and they get referred to as location objects. So a location object can be a civic address of that endpoint, etc. And these location objects, like I said, are validated against the GIS data. Now they're the address points, the road center line layer, and then they store them in the list. And again, if it's in the list, it's assumed that it can be routed by the ECRF if and when it gets delivered that way with a 911 call. The ECRF, those location objects arrive. Maybe it needs to get dereferenced in the list first, but eventually you get a value, and that value queries the GIS data, gets geography, figures out which PSAP polygon it's in, and routes. So it's just the routing is different, and it's important to know kind of how it's different to know like how these calls are routing. A lot of this, these kind of core concepts that I've talked about in the last few slides, NENA's got 3 standards that really lay these things out in more detail if you really want to dig in. We've got our STA, so we know these are standards. They say must and shall, and they define structure and connections. So we have STA 010, which talks about the I3 architecture, that overarching architecture of all things NextGen 911. STA 006, the NextGen GIS data model. So that tells you like the structure of the GIS data layers. And the STA 029, CLDXFCA, basically says here's how those location objects need to be formatted as you pass them through the NextGen system. So that's a lot. And if you're feeling overwhelmed, that's okay. And oh darn, pop quiz. So I promised Kate if I had a few minutes, I was going to go through a bit of a knowledge check, and it looks like I have at least 3 or 4 minutes. So I have a couple of practice questions for folks, and we'll walk through them, and maybe I'll walk through how I would answer the question. And I know my brain may work differently than your brain, or maybe it works exactly the same as your brain. If it is, we need to become besties. But I'm going to walk you through how kind of when I was writing my exam, how I would kind of answer some of these questions. So, and if you think you know the answer, you can drop it in the chat. That's perfectly fine. But our first practice question is, that functional element that provides locations of endpoints, also the entity that provides dereferencing service, exchanging a location reference for a location value. Now, if you already know the answer, that's great, fabulous, and I love that for you. If you're looking at this going, I have no idea, Robert, that's okay. I'm going to walk you through my process. So when I read a question like this, I look and I go, oh, functional element. That's a NextGen 911-y thing. That's not a legacy thing. So on here, what's next gen and what's not. And I look through and I go, okay, function, server, database, selective router database. Well, I know the selective router is legacy, so it's not that. Okay, what else did we talk about in the question? Okay, we're talking about location information. Okay, well, B talks about call routing. We're not talking about call routing in the question, so we know it's not B. So then I would look and say, okay, well, it's either A or it's D. And I might trip myself up and say, oh, functional element, it's got to be this function. But then I'm like, oh no, it's not actually providing, it's providing a service and exchanging one thing for another. And then, oh, okay, well, that's where that dereferencing point is. I know Robert talked about this. That's that LIS where things get dumped and you can go double check them out later, as opposed to the validation function that's validating something. Nothing's talking about validating in the question. So when I would go through it, I would go, okay, perfect. That means I would pick D, and D would be the answer. Second one, current position of an endpoint that originates an emergency call can be geodetic, civic, or a combination thereof. And I would look at it and go, okay, well, we're talking position of a thing. I know some of these words like civic, and maybe I know geodetic. Okay, what do the answers look like? Okay, lat long, that's a location thing. Location object, well, that's a location thing. Location information server, that's a thing. Selective router, that's not an endpoint position anything. That's selective routing, so it's not C. I know, okay, well, we just had location information server in the last question. We know what that does, and this question is asking something different. So it's got to be A or B. And then I would think, okay, well, lat long, that's those degrees and that's those prime meridians and coordinates and geodetic things Robert was talking about. And the question says it can be that or it can be other things. So it can't be. I don't think it's lat long. Oh, it's the location object. It's those customer endpoints. B, and B would be the right answer. 3, space-based navigation system that provides location and time information anywhere on Earth, where there is an unobstructed line of sight of 4 or more satellites. Okay, space. Starlink, that's a space thing. Height above ellipsoid, that's not a space thing. Selective router, that's not a space thing. GPS, that's a space thing. And okay, they're both satellites. But oh, Starlink gives me internet. GPS gives me position, and that's what's in my car for giving me directions. So Robert talked about GPS. The magic behind it was really accurate clocks and time. So it has to be GPS. GPS is your answer. Number 4, there's only 5. Number 4, file of completed updates that is sent to the DBMS provider by all service providers, contains customer TN adds, changes, and deletes. You go, oh, okay, Robert talked about this. This is that 911 extract thing he was going on about. Okay, that is, well, it's legacy. It's not next gen. Is there any next gen things in here? Nope. Okay, crap. They're all legacy things. Okay, well, MSEG, we talked about, that's street address information. Well, there's nothing about street address in the question. Okay, it's not that. ANI, okay, that's phone number. Okay, we do talk about phone number, telephone number in the question, so maybe it's that. Selective router, oh, it's not that. We're not talking about routing anything here. Service order, okay, maybe it's that. So it come down to A or D, and then it's, okay, well, hold on, this is customers have ordered service. Oh, this is that SOI thing where this kicks off the chain. Robert talked about this. It's that service order input. That's A, and A is the answer. And the final one I've got for you, that routing table that contains telephone number to ESM relationships, which determines the routing of 911 calls. And you're sitting here, you think, and you go, oh, okay, ESN, well, that's legacy. Is there any next gen things? Oh, yep, emergency call routing function, that's next gen for sure. So it's not that. Okay, what are we talking about here? ALI database, selective router database, selective router. Well, this is talking about a table. Tables are pieces of data that sit in a database. So it's a database. We're talking about a database here. So it's not the selective router. So then it's, oh, which one is it, alley or selective router? Oh gosh, what was that trick Robert tried to show me? Okay, no, ESN, that does not have the letter A in it. That's not the alley. That's ENS, is selective router. Selective router database is the correct answer. And that's question number 5. And now for real this time, that's the end that I have. Hopefully that answered a couple of questions. Hopefully you learned at least something. And if nothing else, know that ALI has A and ESN has ENS for selective router. But if there are questions, I can stay on a couple of minutes and answer them. If I've put everyone to sleep, I know it's the middle of the night here on the East Coast, but for the rest of the country, I know that you're awake. But hopefully this was helpful and useful for folks. And I think, Jason, you've got a question.
I do. So my question is, in our NG911 world, with a cell phone at a civic address, if the cell phone dials 911 in the NG world, does it resolve to only a lat long location, or is it determined that because it's right in a house per se that's a civic address, would it resolve to a civic address? That's a little hazy for me at the moment.
Ooh. So it could be a couple of things, and it may not be the same every time. The network could deliver the lat long that the device has calculated, or that the network has calculated, and deliver that as a location by value and say, hey, I know where this thing is. I know the geodetic value of this thing, and here it is. Or it may deliver also a location by reference and say, I know this is a cell phone and the location may change over time. So I'm going to give you the link where you can go and get new locations over time, kind of like Rebid, so that you can go and think new location. But for wireless, it's likely going to give you either the geodetic or geodetic plus the reference link to kind of go and get updated location.
So not ever street.
Like yeah. If it's landline, probably specific, but yeah.
Okay, so it's only landlines that would give that would resolve to a civic address. That was kind of what I was thinking, but I just wanted to be sure.
Yeah. Now, if we come up with some whiz bang, algorithm that gets it really certain that it knows the civic address that's associated with its location, I mean, it could pass that's available in that PIDFlow in that location object. But it's likely going to be either the geodetic coordinates and or the reference to go get new geodetic coordinates.
It gets really tricky because on a large parcel of property, if like a farmer's farming and he's in way far away from his house and he dials 911, but that's the closest address, and that's what's plotting in your map, and that's tricky because that might not be the best at this point either, right? So great to have that supplemental information, but may not always be the best location either, right? So yeah, exactly. Lots to think about. Robert, thank you so much for the session today. Absolutely lovely. Are there any other questions for Robert?
We're all asleep.
Oh, everybody's sleeping. All right. I will stop recording.